Welcome. Here in this unit, we're going to talk about the different data structures that exist in Python and why they're interesting to use. So, first, why use data structures? We already have variables. We can already store any amount of information we have in them. Well, if we use specific abstract data structures, they can help us to store and recover the data in specific patterns, in specific ways. All data structures have an interface defined by a set of methods and operations we can perform on them. Most of them can be classified in creation interfaces, access and modifiers, and iteration. Creation means just the constructor creating a new data structure, either an empty one or from a set of data we already have. Accessing and modifying them match the getters and setters we already used in objects, but they have specific names that change when the data structure changes to reflect the inner representation of the structure. And finally, iterators let us go through every element once, such that we can apply operations or search for a specific element and so on. If we use abstract data types, we can ignore the internal implementation of the data structure. For example, we do not care how elements in a list are stored in memory, just the external interface we have to interface with the list. So, for example, how we can append an element to a list or pop an element from it, or just check whether a list contains a given element. The important thing is that even if the implementation changes, the external interface would be the same, and thus our behavior should not change even if the data structure gets better with new versions of Python, or if we use different versions of the data structure. These are the most basic data types that appear most frequently in Python. You already know lists and dictionaries because you use them in CS1. Lists are just a sequence, and they can have repeated elements, and they store the specific sequence. So a different list, so for example ABC and CBA represent different lists. Stacks and queues represent real-life concepts, so for example a stack of plates or a stack of papers. And queues represent, they keep the order of insertion, so for example a queue of people queuing for an event or for a vending machine. Sets are similar to lists, but with two very important distinctions. First, the order of the elements is not important, so BCA is equal to ABC. But each element can only appear once. So if we had a set with A and B and we tried to add B again, then that would fail and the set would remain AB. Finally, we have dictionaries, which you already know, which are very similar to sets. So the elements do not have an order and they can only appear once. But each of the elements will now be called a key and will have a value associated with it. They can be used for many different things, but for example, they can be used for actual dictionaries. And finally, we have graphs, which are a set of nodes connected by arcs or edges. These can represent a map, they can represent a family tree, they can represent any number of relationships between elements. We can classify these data structures into linear and non-linear data structures. In linear data structures, we can find a connection between each element and the next one, either because it's positioned in the next element of a list, or because it has a direct connection to the next element. And in non-linear data structures, you may have multiple elements connected to each other. So for example, in graphs or in a tree, such as a family tree, you may have multiple elements connected, multiple children connected to a given parent. We will focus for now on the linear data structures, specifically in the stack, the queue, and the list. And that's it. I'll see you in the next video.